people. Yeah, no food or drink in the auditorium. That's the one rule. They're super strict about it. We want to have the option to come again if we have, yeah. We don't want to be canceled by the Simon Foundation gods. Okay, great. But yeah, so yeah, rule number 1, no food or drink in the auditorium, but also we actually have lunch on behalf of MacArthur Foundation. We have lunch catered today. Yay! Yeah, it's very delicious. Like the admin has great taste, and so that will happen outside in the auditorium area. Obviously, you are also free to leave and come back for lunch as well, and that will be from 12 to 2. But because we have it catered, it'll actually be a little bit easier for folks if they want to just like eat lunch around the auditorium area, come back, or go outside. And so we'll allow for like a longer Q&A of like maybe like a 5-10 minute buffer. Oh, you can also go to the second floor? There's outside tables. Yeah, this is California. The sun is shining. Sorry, no offense to people from the East Coast. I know, but you also have snow right now. Like, no one's eating outside. Sorry, I know. You're coming all the way from Penn. Thank you. Anyways, let me introduce Hamsa before 1 second. Okay. All right. So, Hamsa Bastani? Okay, great. Is an associate professor of operations, information and decisions, OID, as well as statistics and data science at the Wharton School of the University of Pennsylvania, where she co-directs the Wharton Healthcare Analytics Lab. Her research focuses on developing novel machine learning algorithms for learning and optimization, including methods for sequential decision-making, learning from auxiliary data sources, and designing effective human AI interfaces. Recently, she's been exploring how AI systems affect and augment human behavior with the goal of designing AI tools to help humans thrive. So I'll leave it to you.
Of course, I forgot. Okay, cool. Thank you, Deb, and thank you to all the organizers. This is such a great lineup. It's great to be here. I wanted to talk about some work that largely gives credit to Angel Chung, who is a PhD student who led this kind of large-scale field deployment. Ling Che Kang, who is a faculty at National Taiwan University and helped kind of orchestrate this collaboration with the Taipei Department of Education, and Bastani, who works as a professor at Penn CS and also as my husband. One job is harder than the other. Not asked in which one. But before I get started, I just wanted to give a little bit background about how I got interested in this specific problem and rage a little bit about it, I guess, since I didn't get asked to do a provocation. So in econ, we hear about something called human capital development, where we think about societal performance or a firm's performance as a function of kind of the technology that you have access to, as well as the skill of humans that wield that technology. So a priori, you might think, okay, technology is improving. We have LLMs, it's amazing. Every year there's a new version that's even better. And so overall performance will kind of go up. But that might not be the case if the people that are using the technology are actually reducing their own skill in response to technology improving. Then you might get this kind of counterintuitive behavior that performance actually goes down and we're kind of worse off as a society. And early on, Alp, Osbert, and I ended up writing this paper showing early field evidence that generative AI does cause skill atrophy and kind of over-reliance. So we did this large-scale randomized control trial at a high school for about 1,000 students in math, everyone's favorite subject, of course, where we actually randomized students to having access to ChatGPT with guardrails, or just their textbook and notes. And the most striking finding we had is that the students that practiced math problems with ChatGPT without any guardrails, which is arguably the most common thing that students currently have access to, did 17% worse on immediate subsequent exam where they did not have AI assistance. And what happens, the story's kind of boring. They just ask for answers. They have very superficial conversations. They're like, what is the answer? Is by far the #1 question everybody asks. And then they copy down the answer, and shockingly, they didn't learn anything, and then they do worse on the exam, right? Guardrails can mitigate this harm, but we found that it didn't actually help do better than just using your books or notes. So it's not clear what value the technology is adding, at least in this context and implementation. And so I talked about this to my dad, and he said, that doesn't sound very interesting. Like, shouldn't you try to say something positive? Also, people will like learn over time. And so we actually ran I'm saying we as very generous to myself. My PhD student, Stefanos Poulidis, ran a follow-up study. He's actually an expert chess player, and chess is arguably one of the first places where AI came for knowledge workers. That's a quote from Garry Kasparov. And so he took a 3-month chess intensive training program, and he recruited about 200 chess academy students. So highly motivated cohort that's actually interested in the task, unlike, unfortunately, the high school students doing math who did not enjoy math. And so we tried to understand whether giving students access to AI answers, like giving them agency to ask for answers, was harmful. And so these are like young children who like love playing chess. And we found that basically if we gave students agency, it'd halve their learning. So even though people generally prefer to ask for answers, they don't actually like having had asked for answers later. It's kind of like eating the cookie and then later hating yourself. That's kind of the survey responses we got. So in the beginning, the students actually used a lot of restraint and they didn't ask for a lot of answers. And then over the course of the 3 months, it kind of just linearly went up, the number of questions they asked, which is really my diet cookie pattern as well. So I was like, I relate to this very. And so it's just really hard behaviorally. We're all hyperbolic discounters. And so it's very hard behaviorally to not ask for something when you know it gives you a short-term reward, even though it doesn't even match your own long-term utility, right? And then again, my dad was like, that's not very interesting. Can you say something positive? And I was like, okay. And I think the key ingredient that's missing is this old idea from education, which is that we're missing the productive struggle component, right? Like all of these uses of AI have so far been, let me give you a 24/7 TA or assistant so that you're actually putting less effort to do the same amount of work. And we kind of know that that does not help. There's also a big literature talking about, it's not just about the technology, but it's about the implementation. We've learned that over the years with MOOCs and the one laptop per child policy. And so a lot of the literature, including our own work so far, has been more about improving the chatbot, and maybe we should think a little bit about, are there implementations where we can actually get students to put more effort and engage more using LLMs, right? And this sort of relates, as I mentioned, to this idea of mastery learning, desirable difficulty, zone of proximal development. These are all ideas that say that we should try to target the region in which students struggle just enough so that they learn. They create failures, create struggle, and that's sort of what leads to long-term learning. And this has also been shown, and I thought this was kind of an interesting study. I think Emma was an advisor on this, right? There was an evaluation of Khan Academy that basically showed that there was an educational improvement for students that used the platform, but only for the 5% of students who engaged for at least 30 minutes per week.
It's actually broader, but I wasn't involved in that one. Happy to chat.
Okay, great. Awesome. And this is something we've consistently found in like our own work as well. If we look at the motivated students and the ones that want to exert effort, they may see gains, but your typical student is usually not that student. Yeah.
To measure gains, or do you use the pre-LLM evaluation tools? Like you're still testing them the same way that they always did. You're not upgrading the curriculum to match what people can do with LLMs.
Great question. My dad also asked me this. So I was just going to get to that. So now my interest has been more about how do we achieve productive struggle. So.
Is your dad watching right now?
What? No, he doesn't care. I go home for winter break, I tell him some stuff, and he's like, oh, that sounds boring. Let's do something interesting.
Sorry to remind you of your dad then.
That's cool. I love him. In this paper, not the one I'm talking about today, we actually tried to change the outcome to look at whether students are able to find and fix adversarial problems constructed so that GPT-4 would get it wrong. And we do find that students can be trained to do that. So if our goal is to get students to like engage with the outputs, find mistakes, inspect and fix them, it is doable, but I'm not going to talk about that today. Today I'm going to be talking about this Python certification program that the Department of Education in Taiwan released based on pre-LLM kind of material. It's really about learning basics of coding. And we're going to be thinking about how we can personalize practice problems to match the student's current level of difficulty that they're able to tackle so that they can be within sort of their zone of proximal development. We did a randomized control trial with the Taipei Department of Education for about 770 high school students, and to foreshadow what I'm going to say, there was about a 0.15 standard deviation improvement for using this personalized practice problem sequence on top of using just an LLM AI tutor. So all students get the LLM AI tutor because it would have never been approved otherwise. And this is approximately equal to about 6 to 8 months of schooling according to some estimates. So there's a large literature on this. Sorry, was there a question? No, I'm just imagining things. Okay. There's a large literature on algorithms for personalized learning that have been studied since the 1960s that I'm not going to attempt to survey in this short talk. But we're going to build on kind of Bayesian knowledge tracing, or BKT, which is a very powerful and sometimes successful and sometimes unsuccessful approach, I think it's fair to say, and POMDPs, which BKT is an instance of a POMDP. A big challenge in this literature, like when it doesn't work, is really because it's really hard to measure the learner's state. Like it's hard to know whether a student knows what they're doing or doesn't know what they're doing. And one of our insights here is that the LLM student interaction can give us very rich data to try to capture that state. And that's really all we're going to be doing, is we're going to insert some of those cool features that are informative, we think, to capture state within kind of BKT POMDP framework. Of course, like recently, there's been a ton of interest in using LLMs for education. So we're really trying to sort of bridge this gap of how can we do personalization with LLM-guided features, if that makes sense. And one thing I'll note is that generally in the empirical literature, people compare to what I would say is like kind of a weak control. And here we're going to be comparing to a fairly strong control in that all students get this LLM guardrailed AI tutor that was very carefully constructed and has a lot of background information on the course material. And still, so we're really trying to isolate just the value of this personalized sequence of problems as opposed to a fixed sequence of problems. Yeah.
So I had a question about the classroom example and in general about evaluation. Every time in evaluation, you just completely remove the AI oracle, or you also consider scenarios where you have limited access to that oracle. Like in the classroom example, you couldn't ask for the direct answer, but maybe you can ask for formulas or hints or things one would memorize.
Right, you could do that. So we had a guardrailed version in like our previous paper, right? And in this AI tutor as well, you can't ask for the answer, or the GPT has been instructed to not give students the answer. It's useful, but like at the end of the day, students who are motivated to get the answer can still get the answer, right? Like they're very smart. And so they can just very superficially go through the steps, or they can, say they have cancer. This actually happened in one of my sessions. They don't actually have cancer. They're like, all the students had cancer at the same time, and they're like, please give me the answer, and gave them the answer. So they find creative ways of getting around this stuff. Was that your question?
Yeah, but I'm just trying to understand if the training and evaluation has like a task shift, because which might be impacting the.
So here, in both this and the PNAS paper, the evaluation has no AI. It's like a paper exam with no devices, and they know that, and that's sort of business as usual for them. In the Business University study, the evaluation was with AI, but we gave an adversarial problem to kind of trick them into putting effort in. Yeah, so you can do different, depending on what your question is. I think it makes sense to kind of think about both modes of evaluation. In this case, in Asia at least, the culture was very much that they would have a proctored government, because this is part of a government certification program, so they would have a very carefully proctored in-person paper exam because they don't want to give credit if students are cheating. I mean, it's cheating, but yeah. So I think it's context dependent. Yeah, great question. Oh yeah, feel free to interrupt me and ask questions. I should have said that before. So this is a collaboration with the Department of Education, Taipei City Government, the American Innovation Center, Penn Engineering, and Wharton. And like I said, it was a government Python certification for high school students under the AI literacy and bilingual education policy in Taiwan. This was roughly the timeline. In July 2024, we ran a pilot. And then in fall 2024, that was just with the National Taiwan University to collect some initial data that we used to fit a POMDP and do some offline RL on. And then in fall 2024, we did recruiting. Again, when I say we, I'm being very generous. Angel did recruiting. There were 2 briefings, teachers, one for teachers and one for students and parents, to get schools interested and parents interested. And then in Jan 2025, the project launched and was like a large media event. And then in spring 2025, there was actually a field RCT for 5 months, February to June. And we enrolled about slightly over 1,000 students across 10 high schools in Taiwan. 2 were private and 8 were public. The randomization occurred at the student level, so we can control for kind of school-specific fixed effects. And out of the 1,047, a few were seniors and had to take an accelerated schedule. A bunch of them didn't finish the course. So we had roughly about 700, almost 800 students in the final kind of sample. The students were largely in 10th grade, partly because the seniors had to take this accelerated thing, and so they didn't have a comparable outcome variable. And most of them were Python beginners, either first-time learners or beginners, self-reported, of course. A very small number, I think it was like 1 student who had like competition level, like International Computer Olympiad kind of level of a skill. Not sure why they were taking an intro programming class. For the large part, you can think of them as beginners. Yeah. Half, I guess. This is the platform interface. Let me see if this like plays. So it's in Chinese, as you might expect. And so these are like the different modules that you can go to. There's like a course video that plays up here. There's a place for you to write your Python code for you to practice. And then there's like a practice problem that shows up. There's an AI assistant chatbot here that you can ask for help if you're confused. And then it'll give you feedback on like whether your test failed or not. It's coding, so like even if a student has mastered a concept, they probably will get a couple of failures or compile issues. And so it can be tricky to kind of figure out, mastery, and that's kind of what we're trying to do. And there's different types of problems, and all right, I'll probably stop the video here. But this is kind of useful for us to capture a bunch of rich interaction data that we normally wouldn't have available. So for example, meaningful attempts, like how many times they meaningfully changed the code in their code base before they resubmitted, because a lot of times they'll just change a character or change a comment. Like you don't want to count that as number of attempts. Meaningful code edits, again, not just changing a variable name, but like doing something that's like meaningfully different. The quality of the chat with the assistant, like are you just saying, oh, it doesn't compile, help me debug, which is not an uncommon conversation. Or are you actually asking, like I have this specific issue with my function, what do you think is going wrong? So the questions, the practice problems themselves were actually generated using OpenAI as well, with questionable accuracy. So basically you got all the materials, it generated a bunch of problems, and then the TA team sat and verified the accuracy. By the end, I think they basically said they would have preferred to write them from scratch because this loop was really annoying. But they did, and eventually we got a bank of problems for each module, 40 problems per module. That is where the practice problems will be drawn from. Students were, so this is from the pilot data. So we took the platform features, and then we also took the pilot data where we gave them random sequences of practice problems. We fit a POMDP, and we tried to see whether these platform interactions were actually predictive of parameters in the POMDP, like their initial knowledge state or their mastery ceiling state, right? And we did find some evidence suggesting that meaningful code edits, average growth of code edits, chat quality, et cetera, were predictive. Yes, I will show you in a second. Yeah. Sorry, I did not give any information yet, but these features were useful is all I'm trying to say so far. Okay, here's the POMDP framework. So this is a little bit like BKT, but a little bit more complicated, I guess. But you have a belief state. You have the true state of whether the binary state, same as BKT, of like whether you've mastered this topic or not. And then you take an action based on that. Oh, sorry, I should have said. This belief state is based on the features that we learned from model-based RL from the pilot data. And then we take an action of like whether we're going to give them an easy, medium, hard, or very hard problem from the problem bank based on what we think their belief state might be. And then we see an outcome or an observation. So like this student failed. Just because they failed doesn't mean they haven't mastered the topic. Like everyone tends to fail a few times. And then we also observe a bunch of features like how many code attempts they took before they finally got the right answer, and so on. Then we update our belief state, and then we move on to kind of the next action. We give them a simpler true-false problem because they got the last problem wrong. This they get right, and then we update our state belief, and so on. So nothing fancy, yeah.
The labelings of the hard, easy, very hard.
Oh, that was done by the TAs.
So the TAs looked at, so the GPT was instructed to just randomly generate problems, or?
No, they have GPT was given all the course materials from before, and so there's already a classification of like what is easy, medium, hard. So in the fixed sequence, you usually get like too easy, too medium, too hard, too very, like goes progressively, and so it's sort of already defined. For example, these true-false questions are easy, so they're just a fundamentally different structure of problem.
Got it. And so when you're doing the knowledge tracing, the questions that are being, or the concepts that are being tracked are like specific topics, and the next question is based on that topic.
This is for this module. So every module, the student is asked to do at least 15, a module's 2 weeks. You have to do at least 15 practice problems. You can do as many as the full 40. Surprise, surprise, people usually do 15 exactly. Either it's going to be drawn from this like POMDP kind of framework, or it'll be like a fixed ascending sequence, which this is showing me my slides are super out of order because I'll talk about that later.
Also to clarify, they're generating a unique question, like a unique problem for each individual student.
The problem bank is fixed, sorry.
Okay.
There's a fixed problem bank that was already pre-generated and everything was verified because we can't give students problems that are wrong because they will hate us. And these are very competitive kids, so they get very stressed out too. Imagine you're a high school student and you want a university Python certification, right? Like cream of the crop. So they're all verified and it's being drawn from that fixed bank.
I see.
Yeah.
All right.
Other questions? Thanks, guys. Cool. Okay, so this is the RCT design, your question, sorry. So all students get the AI tutor, right? So this was like a very carefully built, nothing intellectually novel here, but it's based on GPT-4. There's a set of extensive pedagogical guardrails on it. The students are required to do 15 practice problems per module. They optionally can do more. There's up to 40. Rarely we saw students do more than the 15 minimum, but they wanted to get kind of credit. Arm 1 is going to be the standard sequence of representative problems with ascending difficulty. So you'll get like a few easies, a few mediums, a few hards, and a few very hards. And this was based on kind of the course has been taught for many years at National Taiwan University, has very high ratings on Coursera and so on. Arm 2 is this sort of adaptive sequence of problems with personalized difficulty using RL. Everything else about the course is fixed. And so it's like a very small tweak, right? We did baseline and mid-course surveys where we collected their demographics, their learning background, their AI usage and perception, just as like potential covariates to look for heterogeneity. And like I said, the outcome at the end was like this in-person paper exams. It was like a picture. It was pretty draconian. There was like a lot of proctors monitoring to make sure that no one was cheating. A couple students were caught cheating, and then they were kind of removed from the sample. No digital devices, clearly. Any questions? Yeah.
Do you have any idea of whether people were using LLMs like outside of the guardrail tutor, and if that might correspond to like if people didn't have a lot of observed AI usage, if you might think that they were using it in like a different browser?
Yeah, that's a great question. So that's why we don't use any of that information in our POMDP updates. Like their self-reported AI usage or self-reported perception, we don't use. For the coding, because their code that they're writing is connected to the GPT tutor, which is also connected to the course materials, you kind of expect the tutor to have like a little bit better quality. But if you don't believe that, that's fine. That's just gonna reduce our treatment effect, right? Because basically you'd be saying that these students are really the same, it's just one of them is like going off platform to get more help.
So
Yeah.
the usage is self-reported, and you expect that to like include whether.
We don't really care about the self-reported usage. The only thing that we don't care whether or not they're going off platform. If they go off platform, the student interaction features that we're extracting are just going to be less informative, right? Because like we don't actually see their meaningful code edits, and so that will just make our algorithm perform worse. Yeah.
Quick question. So
Yes.
is the treatment a combination of the POMDP adaptive question sequencing and the AI tutor with guardrails? So it's like both of those?
No, the AI tutor is for everyone.
Oh, everyone gets
Yeah,
it.
so we're just looking at the POMDP sequencing. That's what I meant, that it's a strong control, because the treatment and control are actually kind of all getting the best of pedagogical instruction at the time. Because these are high school students, they don't have access to the university TAs, and this is a university level class. So we kind of had to give them the AI tutor, because who else will they go ask for help? They can't go to the high school teacher because they might not have Python knowledge. Yeah.
And are you also using their chats with the AI tutor to suggest the next problem?
Yeah, so that's
Okay.
part of the meaningful chat quality feature. Yeah.
Yeah, like
Yeah.
a metric for that goes into the.
Yes, exactly. Yeah.
Thanks.
Great question. Yeah.
Is most of the adaptivity over the problem difficulty, or also over like coverage of the content space?
So it's by module, so presumably it's a pretty homogeneous set of problems, right? Like we're covering if loops, and I don't actually know Python myself. I read all the modules and I was like, sounds good. So if you're covering loops, all the problems are about loops, right? And then it's about function logic, right? So it's module specific, and it's only sequencing within the module. Yeah.
And if you tried something like, if you get the question right, ask a harder question, and like.
If you get the question right, it may have you ask a harder question. So with coding, the tricky thing is that people always get the question wrong, right? Because you always have like a typo or something in like your code. So if you get it wrong once or twice, but it's like a minor error, then you try to learn that like the student has mastered the concept. They're just very typo prone, right? Because like in a written exam, they actually would get most of the partial credit or even full credit for like not having some syntax, right? Yeah.
Is the state only binary for the whole module, or is there like a set of skills for a module that they're
No, it's binary for the whole module. Yeah, so you could probably do better. I don't know, it's like a first step, yeah. But yeah, it's like a per module mastery. Great question. Oh, sorry, I should shut up soon. Okay. Okay, cool. I don't think I have much more. So the main results. So this is the descriptive plot. So like I saw this and I was like, oh, thank God. So it took like a year and a half to set this up, and I was like, we're not running it again. Okay. So then we looked at the standardized exam score with and without controls in like a linear regression, the usual stuff, right? And so that's the treatment variable, and it's kind of similar looking for kind of both sets, but basically the long story short, the RL group did about 0.15 standard deviations better than the group without the personalized sequence of problems. This is about, I thought I said 6 to 8, now it says 8 to 10. Okay, it's like some reasonable number of months of school learning. So it's somewhat significant given that, all we did was, change the problem difficulty. The stuff that I was happy about, oh, not this, okay. So the gains are larger for Python beginners, and the gains were also larger for students at lower tier schools. Like, it's a little bit like, not clear if it's like super statistically significant, but I think directionally it's moving towards reducing inequity rather than increasing inequity, which we felt good about. If we look at the number of problems the two groups solved, both groups completed a similar number of problems. Again, because people really only like doing the bare minimum of what's required of them. These are busy high school students. They're already taking their high school coursework. They're doing a bunch of other stuff, and then they're doing this on the side. So it's already kind of impressive that they were able to do this. The RL group had a higher chat quality, right? So like, this is like a more challenging set of prompts, and they had more engaged and less superficial discussions. Instead of just asking for answers, they were asking kind of deeper and more interesting questions. This suggested that engagement was improving, which is really what we set out to do, is can we use AI and LLMs in a way in education that it's not reducing productive struggle and engagement, but rather increasing it. And we did a suggestive kind of mediation analysis. I have thoughts on mediation analyses in general. They make strong causal assumptions, but I thought, well, we did it just to, kind of give a sense of what might be happening. And we found that a lot of the treatment effect was traveling through total time spent and number of total attempts. So generally, there were more time was spent in the RL group and more attempts in the RL group. So it suggests kind of more productive struggle in this group, and that might be what is causing the improvement. On average, the RL arm had slightly more difficult problems that they got from the bank. So we were like, are they just getting harder problems and they do better? We looked at the pilot data where we gave people random sequences of problems, and we found that increased difficulty did not improve outcomes. In fact, it actually slightly hurt outcomes. So it seems to be that it's really the matching, that you're getting harder problems when you've kind of already learned how to do the easy problems, and that's kind of where we're seeing the improvements from. All of these arguments are kind of not super causal, just trying to get a sense of why we're seeing the improvements that we might be seeing the improvements we are seeing. It's English. Okay, so I think this is basically just scratching the surface. So we've shown that AI can harm learning if we undermine productive struggle and kind of past work, and hoping that this kind of argues that careful design and implementation can instead support learning by increasing engagement and productive struggle. These are some of the comments we got from the students. It said, it's great, solve my self-study problems, unlike ChatGPT, gives me clear answers and makes me think, helps me spot mistakes faster and practice more, which again, partly we cherry-pick these comments, but they actually want to try harder, at least some of the students, which, we felt good about. Very different from our past work where students just wanted to do less. So we felt good about this. Anyway, thank you for listening. This is, again, really Angel's work, and Lin Chiekang made this totally possible, and Osborne. Thank you. Do I take questions or leave?
Yeah, we can take a couple questions while the next speaker comes up.
Cool. Yeah.
So, coming from the healthcare context,
Yeah,
there's a lot of monitoring and feedback. I'm just thinking, do you see an upper bound? Because you're talking about students. In healthcare, there's a lot of monitoring feedback you can give into professionals, working professionals.
Yeah.
And especially where you have this separation of the MD and then the nurse practitioner and PA.
Yeah.
People are building these AI systems that layer on top of mid-level providers to try to skill them up.
Right.
I'm curious, where do you see this as the level of expertise of the learner goes up?
I think healthcare has generally been challenging. All the results that I've seen mostly,
In healthcare, I'm just saying
No, but in general. You've probably seen Nikhil Agarwal's paper about how radiologists take AI recommendations and then produce uneven improvements because their people are bad Bayesian updaters. Yeah, sorry.
I still would separate that from going to the expert versus still some intermediate, but it's not a high school student. It's a working professional.
Like a physician assistant or RN.
Like a working professional, but who's not the domain expert in that domain.
I think that worries me a lot because the problems that are easy are the ones that the AI can probably do, and where you need human intervention is where you need people, experts who are experienced. And so if you're kind of offloading that to the PA and offloading to the AI, you might not get. Maybe this is a longer conversation.
No, I'll follow up with
Yeah.
we're already offloading the easy cases. Yeah,
Right, but I don't know that that's good. We haven't tracked it, right? At Penn Med, we have a lot of examples where patients with really heavy chronic conditions have issues in their medical notes from DAX-ambient support, and then there's no recourse or process to resolve those errors just because we haven't set up those systems. So in healthcare, cost cutting kind of takes precedence, unfortunately, over. I have a lot of opinions. Sorry, I'll shut up.
Careful what you say on your talk was recorded. Yeah, I was gonna say very quickly, like I think the non-expert user is like very evident in the education space, where like I think there's like an HCI adjacent assumption that like users can kind of like play this verifier role, and in many cases like they're using an AI system to assist them because they don't know the information. Yeah. Like with EGFR, for example, it's like we thought like nephrologists don't really use EGFR. It's like pharmacists and other sort of health workers that don't have a good gauge on kidney function. They'll use a clinical decision support tool because they don't know, right? So I think the non-expert users, like students, are definitely peak that. Yeah. Okay, thank you. Clap, clap. Thank you. So next we have Emma. Let me just pull up